Always check with local authorities. Consult the local building department or electrical inspector to confirm if there are any code prohibitions against using a power company trench for an electrical feeder cable. Safety concerns are paramount. You have valid concerns about working near the power company's live wires. Do not attempt any excavation or trenching that could compromise their safety or yours. There may be unknown conditions. It's not clear if there are any obstacles or underground utilities in the path that could pose a hazard during excavation. Consider the feasibility. It seems the power company trench only covers part of the distance needed to reach the garage. You would need to dig an additional trench to complete the run, which may not be practical or cost-effective. Running an electrical feeder cable to a detached garage typically requires permits and inspections. You would need to obtain the necessary approvals before proceeding. Alternatives should be considered. Discuss with the homeowner the possibility of digging a separate trench dedicated to the underground feeder cable, ensuring a safe distance from the power company wires. If the distance to the garage is short, consider overhead wiring using weather-resistant conductors. This avoids any trenching risks. Politely inform the homeowner that you are not comfortable sharing a trench with the power company wires due to safety concerns and advise them to consult with the power company directly about other options. Keep the homeowner informed of your decision and provide them with clear reasons for it. Offer alternative solutions or recommend a qualified electrician who can assist them with the project. When planning electrical work, especially concerning detached garages and underground wiring, several factors must be considered to ensure safety, compliance, and practicality. Firstly, always prioritize safety. Working near live electrical wires poses significant risks, and it's crucial to take precautions to protect yourself and others. Never attempt any excavation or trenching that could compromise the integrity of the power company's infrastructure or your personal safety. Secondly, consult with local authorities. Electrical codes and regulations vary depending on your location, so it's essential to check with your local building department or electrical inspector to confirm whether there are any prohibitions or specific requirements regarding the installation of electrical feeder cables in shared trenches. Thirdly, assess the feasibility of the project. Consider the distance between the power source and the detached garage, as well as any obstacles or underground utilities that may impede the installation process. If the power company's trench only covers a portion of the required distance, additional trenching may be necessary, which could add to the overall cost and complexity of the project. Fourthly, explore alternative solutions. If sharing a trench with the power company is not feasible or advisable, consider other options such as digging a separate trench dedicated solely to the electrical feeder cable. This allows for a safer and more controlled installation process, minimizing the risk of damage to existing utilities or interference with the power company's infrastructure. Alternatively, if the distance to the garage is relatively short, you could explore the possibility of using overhead wiring with weather-resistant conductors. This eliminates the need for trenching altogether and reduces the potential for underground hazards. Fifthly, obtain necessary permits and inspections. Before commencing any electrical work, make sure to obtain all required permits from your local authorities. This ensures that the installation meets all applicable codes and standards, and that it is inspected by qualified professionals to verify its safety and compliance. Finally, communicate effectively with the homeowner. Clearly explain your concerns and recommendations, providing them with all available options and their associated costs and benefits. If you are uncomfortable proceeding with the project due to safety concerns or code restrictions, politely decline the request and recommend that they consult with the power company directly or seek assistance from another qualified electrician. By carefully considering these factors and taking appropriate precautions, you can ensure a safe, compliant, and successful electrical installation for the detached garage. Remember to prioritize safety, consult with local authorities, assess feasibility, explore alternatives, obtain permits and inspections, and communicate effectively with the homeowner throughout the process. If the homeowner asks about running a new underground feeder cable from the house panel to the detached garage panel using the power company's trench, there are several considerations to take into account. Firstly, safety is paramount. Working in close proximity to live electrical wires can be extremely dangerous. You should never attempt to work on or near the power company's equipment without their explicit permission and guidance. Secondly, code compliance is essential. Electrical installations must adhere to the National Electrical Code, as well as any local codes and regulations. These codes specify minimum requirements for conductor size, burial depth, and protection against physical damage, among other things. Thirdly, coordination with the power company is crucial. Before commencing any work, you must contact the power company to obtain their approval and guidance. They may have specific requirements or restrictions regarding the use of their trench, as well as safety protocols that must be followed. Fourthly, proper installation techniques are necessary. The underground feeder cable must be installed in accordance with the National Electrical Code and the power company's instructions. This includes using the correct type of cable, ensuring proper burial depth, and providing adequate protection against physical damage. Fifthly, permits and inspections may be required. Depending on your location, you may need to obtain permits from your local building department before commencing any electrical work. Once the installation is complete, it must be inspected by a qualified electrical inspector to ensure that it meets all applicable codes and standards. Finally, documentation is important. Keep detailed records of all work performed, including permits, inspections, and any communication with the power company. This documentation can be helpful in the event of future maintenance or repairs. If you are not comfortable or qualified to perform this type of work, it is always best to hire a licensed and experienced electrician. They will have the knowledge, skills, and equipment necessary to safely and properly install the underground feeder cable, ensuring that it meets all applicable codes and regulations. If you are considering using a power company trench for your underground feeder cable installation, it is important to be aware of the potential hazards and risks involved. Live electrical wires can be extremely dangerous, and any contact with them can result in serious injury or death. In addition to the safety risks, there are also potential code compliance issues to consider. Electrical codes and regulations vary depending on your location, and it is important to ensure that your installation meets all applicable requirements. If you are not familiar with these codes, it is best to consult with a qualified electrical inspector. Coordination with the power company is also essential. Before commencing any work, you must contact the power company to obtain their approval and guidance. They may have specific requirements or restrictions regarding the use of their trench, as well as safety protocols that must be followed. Proper installation techniques are necessary to ensure the safety and reliability of your electrical system. The underground feeder cable must be installed in accordance with the National Electrical Code and the power company's instructions. This includes using the correct type of cable, ensuring proper burial depth, and providing adequate protection against physical damage. Permits and inspections may be required depending on your location. You may need to obtain permits from your local building department before commencing any electrical work. Once the installation is complete, it must be inspected by a qualified electrical inspector to ensure that it meets all applicable codes and standards. Documentation is important. Keep detailed records of all work performed, including permits, inspections, and any communication with the power company. This documentation can be helpful in the event of future maintenance or repairs. If you are not comfortable or qualified to perform this type of work, it is always best to hire a licensed and experienced electrician. They will have the knowledge, skills, and equipment necessary to safely and properly install the underground feeder cable, ensuring that it meets all applicable codes and regulations. The National Electrical Code, or NEC, provides comprehensive guidelines for electrical installations in the United States. When dealing with underground feeder cables for detached garages, there are several NEC articles that are particularly relevant. Article 225 Outside branch circuits and feeders covers the requirements for electrical wiring located outside of buildings. This includes feeder cables that run from the main building to a detached garage. Article 300 Wiring Methods outlines the general requirements for wiring methods, including those used for underground installations. This article addresses issues such as protection against physical damage, proper burial depth, and the use of approved raceways or cables. Article 310, Conductors for General Wiring, specifies the requirements for conductors used in electrical wiring, including their ampacity, insulation, and suitability for wet or dry locations. This article is important for selecting the appropriate conductors for the underground feeder cable. Article 314, Outlet device, pull, and junction boxes, conduit bodies, fittings, and manholes, covers the requirements for enclosures used in electrical wiring, including those used for underground installations. This article addresses issues such as the size and type of boxes, as well as their protection against moisture and corrosion. Article 334, Non-metallic sheet cable types NM, NMC, and NMS, provides the requirements for non-metallic sheet cables, which are commonly used for residential wiring. This article specifies the types of cables that are permitted for underground installations, as well as their installation requirement. Article 340, Underground feeder and branch circuit cable type UF, covers the requirements for underground feeder and branch circuit cables which are specifically designed for direct burial in the earth. This article specifies the types of cables that are permitted for underground installations, as well as their installation requirements. When installing an underground feeder cable to a detached garage, it is essential to comply with all applicable requirements of the NEC. This includes selecting the appropriate conductors, providing adequate protection against physical damage, ensuring proper burial depth, and using approved wiring methods and enclosures. Failure to comply with the NEC can result in safety hazards, code violations, and potential liability. It is always best to consult with a licensed and experienced electrician to ensure that your electrical installation meets all applicable requirements. They will have the knowledge, skills, and equipment necessary to safely and properly install the underground feeder cable, ensuring that it complies with the NEC and local codes and regulations. The minimum burial depth for underground feeder cables depends on several factors, including the type of cable, the voltage, and the location of the installation. The NEC specifies minimum burial depths for various types of cables and wiring methods in Table 300.5. For example, direct buried cables such as type UF cable are typically required to be buried at a minimum depth of 24 inches below grade. However, this depth may be reduced to 18 inches if the cable is installed in a raceway, such as rigid metal conduit or intermediate metal conduit. Cables installed under residential driveways or parking areas are typically required to be buried at a minimum depth of 18 inches, regardless of whether they are installed in a raceway. Cables installed under public streets or alleys are typically required to be buried at a minimum depth of 24 inches. In addition to the NEC requirements, local codes and regulations may also specify minimum burial depths for underground feeder cables. It is important to check with your local building department or electrical inspector to determine the specific requirements in your area. When installing an underground feeder cable, it is essential to ensure that the cable is buried at the proper depth to protect it from physical damage and to prevent it from becoming a hazard. The cable should be buried deep enough to avoid being damaged by digging, landscaping, or other activities. It should also be buried deep enough to prevent it from being exposed by erosion or settling of the soil. If the cable is installed in a raceway, the raceway should be buried at the proper depth and should be protected from physical damage. The raceway should also be properly sealed to prevent moisture from entering. When backfilling the trench, use caution not to damage the cable or raceway. The backfill material should be free of rocks, debris, and other sharp objects that could damage the cable. The backfill material should be compacted to prevent settling and to provide support for the cable. The size of the underground feeder cable required for a detached garage depends on the electrical load that the garage will be carrying. The electrical load is the total amount of power that will be used by all of the electrical devices and appliances in the garage. To determine the size of the feeder cable, you will need to calculate the electrical load of the garage. This can be done by adding up the wattage of all of the electrical devices and appliances that will be used in the garage. For example, if the garage will have a 1500 watt heater, a 100 watt light bulb, and a 500 watt power tool, the total electrical load would be 2100 watts. Once you have calculated the electrical load, you can use the NEC to determine the size of the feeder cable required. The NEC specifies the ampacity of conductors for various types of wiring methods. The ampacity of a conductor is the amount of current that it can safely carry without overheating. To determine the ampacity of the feeder cable, divide the electrical load in watts by the voltage of the electrical system. For example, if the electrical load is 2100 watts and the voltage is 120 volts, the ampacity would be 17.5 amps. Once you have determined the ampacity of the feeder cable, you can use the NEC to select the appropriate conductor size. The NEC specifies the conductor size for various ampacities in Table 310.16. For example, a 14 American wire gauge copper conductor has an ampacity of 15 amps, a 12 American wire gauge copper conductor has an ampacity of 20 amps, and a 10 American wire gauge copper conductor has an ampacity of 30 amps. In the example above, an ampacity of 17.5 amps would require a 12 American wire gauge copper conductor. In addition to the conductor size, you will also need to select the appropriate type of insulation for the feeder cable. The NEC specifies the types of insulation that are permitted for various applications. For underground feeder cables, Type UF cable is commonly used. Type UF cable is a direct burial cable that is suitable for wet locations. It is important to consult with a licensed and experienced electrician to ensure that you select the appropriate size and type of feeder cable for your detached garage. They will have the knowledge, skills, and equipment necessary to safely and properly install the feeder cable, ensuring that it complies with the NEC and local codes and regulations. The NEC requires that all electrical circuits be protected by overcurrent protection devices such as circuit breakers or fuses. Overcurrent protection devices are designed to protect electrical circuits from overloads and short circuits. An overload occurs when too much current is flowing through a circuit. This can happen if too many electrical devices or appliances are connected to the circuit at the same time. A short circuit occurs when there is a direct connection between two conductors in the circuit. This can happen if the insulation on a wire is damaged or if a wire comes loose from a terminal. When an overload or short circuit occurs, the overcurrent protection device will trip or blow, interrupting the flow of current to the circuit. This prevents the circuit from overheating and potentially causing a fire. The size of the overcurrent protection device must be matched to the ampacity of the circuit. The ampacity of a circuit is the amount of current that it can safely carry without overheating. The NEC specifies the maximum size of overcurrent protection devices for various types of circuits in Table 240.4. For example, a 15 amp circuit requires a 15 amp circuit breaker or fuse, a 20 amp circuit requires a 20 amp circuit breaker or fuse, and a 30 amp circuit requires a 30 amp circuit breaker or fuse. It is important to select the correct size of overcurrent protection device for your electrical circuits. If the overcurrent protection device is too small, it will trip or blow frequently, interrupting the flow of current to the circuit. If the overcurrent protection device is too large, it will not protect the circuit from overloads or short circuits, which could potentially cause a fire. In addition to the size of the overcurrent protection device, you will also need to select the appropriate type of overcurrent protection device for your electrical circuits. Circuit breakers and fuses are the two most common types of overcurrent protection devices. Circuit breakers are reusable devices that can be reset after they trip. Fuses are one-time devices that must be replaced after they blow. It is important to consult with a licensed and experienced electrician to ensure that you select the appropriate size and type of overcurrent protection devices for your electrical circuits. They will have the knowledge, skills, and equipment necessary to safely and properly install the overcurrent protection devices, ensuring that your electrical system complies with the NEC and local codes and regulations. When installing an underground feeder cable to a detached garage, it is important to consider the potential for ground faults. A ground fault occurs when there is an unintentional connection between a conductor and ground. This can happen if the insulation on a wire is damaged or if a wire comes loose from a terminal. When a ground fault occurs, current will flow through the ground path back to the source of power. This current can be dangerous and can potentially cause a fire. To protect against ground faults, the NEC requires that all electrical circuits be protected by ground fault circuit interrupters, or GFCIs. GFCIs are devices that monitor the current flowing through a circuit and detect any imbalances that could indicate a ground fault. When a ground fault is detected, the GFCI will trip, interrupting the flow of current to the circuit. GFCIs are typically required in wet locations such as bathrooms, kitchens, and outdoor areas. However, the NEC also requires GFCIs to be installed on circuits that supply power to detached garages. This is because detached garages are often used for activities that involve water or moisture, such as washing cars or working on lawn equipment. GFCIs can be installed in several different ways. They can be installed as circuit breakers in the electrical panel, as receptacles in the wall, or as portable devices that plug into a receptacle. It is important to select the appropriate type of GFCI for your application. When installing a GFCI, it is important to follow the manufacturer's instructions carefully. The GFCI must be properly wired and grounded to function correctly. It is also important to test the GFCI regularly to ensure that it is working properly. To test the GFCI, press the test button on the device. The GFCI should trip, interrupting the flow of current to the circuit. If the GFCI does not trip, it may be defective and should be replaced. It is important to consult with a licensed and experienced electrician to ensure that you install GFCIs properly in your electrical system. They will have the knowledge, skills, and equipment necessary to safely and properly install the GFCIs, ensuring that your electrical system complies with the NEC and local codes and regulations. When installing an underground feeder cable to a detached garage, it is also important to consider the potential for voltage drop. Voltage drop is the decrease in voltage that occurs as electricity flows through a conductor. Voltage drop can be caused by several factors, including the length of the conductor, the size of the conductor, and the amount of current flowing through the conductor. Excessive voltage drop can cause problems with electrical devices and appliances. It can cause lights to dim, motors to run slowly, and appliances to malfunction. To minimize voltage drop, it is important to select the appropriate size of conductor for the feeder cable. The NEC provides guidelines for calculating voltage drop in electrical circuits. The NEC recommends that voltage drop should not exceed 3% for branch circuits and 5% for feeders. To calculate voltage drop, you will need to know the length of the conductor, the size of the conductor, and the amount of current flowing through the conductor. You can then use the following formula to calculate voltage drop. Voltage drop equals 2 times K times I times D divided by circular mils, where K is the constant representing the conductor material, typically 12.9 for copper and 21.2 for aluminum. I is the current in amps, D is the one-way distance in feet, and circular mils is the cross-sectional area of the conductor. The NEC provides tables that list the circular mils for various conductor sizes. Once you have calculated the voltage drop, you can compare it to the NEC recommendations. If the voltage drop exceeds the NEC recommendations, you will need to increase the size of the conductor. In addition to selecting the appropriate size of conductor, you can also minimize voltage drop by shortening the length of the conductor. This can be done by locating the detached garage closer to the source of power. It is important to consult with a licensed and experienced electrician to ensure that you properly account for voltage drop when installing an underground feeder cable to a detached garage. They will have the knowledge, skills, and equipment necessary to calculate voltage drop and select the appropriate size of conductor, ensuring that your electrical system complies with the NEC and local codes and regulations. When planning an electrical installation for a detached garage, there are several different wiring methods that can be used. The most common wiring methods include underground feeder cable, or UF cable, conduit, and overhead wiring. UF cable is a type of direct burial cable that is designed for underground use. UF cable is typically used for feeders that run from the main building to the detached garage. UF cable is relatively inexpensive and easy to install. However, UF cable is not as well protected from physical damage as conduit. Conduit is a type of protective tubing that is used to encase electrical wires. Conduit can be made of metal or plastic. Conduit provides excellent protection for electrical wires from physical damage. However, conduit is more expensive and more difficult to install than UF cable. Overhead wiring is a type of wiring that is installed above ground. Overhead wiring is typically used for feeders that run from the main building to the detached garage. Overhead wiring is relatively inexpensive and easy to install. However, overhead wiring can be unsightly and can be damaged by weather or trees. The best wiring method for your detached garage will depend on several factors, including the distance between the main building and the detached garage, the type of soil, the climate, and your budget. If the distance between the main building and the detached garage is short, UF cable may be a good option. If the soil is rocky or the climate is harsh, conduit may be a better option. If you are on a tight budget, overhead wiring may be the most affordable option. It is important to consult with a licensed and experienced electrician to determine the best wiring method for your detached garage. They will have the knowledge, skills, and equipment necessary to safely and properly install the electrical wiring, ensuring that your electrical system complies with the NEC and local codes and regulations. Before commencing any electrical work, it is important to obtain all necessary permits from your local building department. Electrical permits are required for most types of electrical work, including the installation of underground feeder cables to detached garages. Electrical permits are designed to ensure that electrical work is performed safely and in accordance with the NEC and local codes and regulations. To obtain an electrical permit, you will need to submit an application to your local building department. The application will typically require you to provide information about the scope of the work, the location of the work, and the name and license number of the electrical contractor who will be performing the work. Once your application has been approved, you will be issued an electrical permit. The electrical permit will typically be valid for a specific period of time. It is important to keep the electrical permit on the job site during the electrical work. The electrical inspector will need to see the permit before they can inspect the electrical work. After the electrical work has been completed, you will need to schedule an electrical inspection with your local building department. The electrical inspector will inspect the electrical work to ensure that it has been performed safely and in accordance with the NEC and local codes and regulations. If the electrical work passes inspection, the electrical inspector will sign off on the electrical permit. The signed electrical permit is proof that the electrical work has been completed in compliance with the NEC and local codes and regulations. It is important to consult with your local building department to determine the specific requirements for obtaining electrical permits in your area. They will be able to provide you with information about the application process, the fees, and the inspection requirements. If you are not familiar with electrical codes and regulations, it is best to hire a licensed and experienced electrician to perform the electrical work for you. They will be familiar with the permit process and will be able to ensure that the electrical work is performed safely and in accordance with the NEC and local codes and regulations. The cost of installing an underground feeder cable to a detached garage can vary depending on several factors, including the distance between the main building and the detached garage, the type of soil, the wiring method used, and the labor rates in your area. The cost of the materials for the underground feeder cable will typically range from $500 to $1,500. The cost of the labor for the underground feeder cable will typically range from $500 to $2,000. The total cost of installing an underground feeder cable to a detached garage can range from $1,000 to $3,500. Here are some of the factors that can affect the cost of the installation: the distance between the main building and the detached garage. The longer the distance, the more materials and labor will be required. The type of soil. If the soil is rocky or difficult to dig, the installation will be more expensive. The wiring method used. Conduit is more expensive to install than UF cable. The labor rates in your area. Labor rates vary from area to area. To get an accurate estimate of the cost of installing an underground feeder cable to your detached garage, it is best to get quotes from several licensed and experienced electricians. Be sure to ask the electricians to provide you with a detailed breakdown of the costs, including the cost of materials, the cost of labor, and the cost of any permits that may be required. When choosing an electrician, be sure to check their references and make sure that they are properly licensed and insured. You should also ask the electrician if they are familiar with the NEC and local codes and regulations. It is important to hire an electrician who is qualified to perform the electrical work safely and in accordance with the NEC and local codes and regulations. If you are considering doing the electrical work yourself, be sure to familiarize yourself with the NEC and local codes and regulations. Electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself from electrical shock. It is also important to obtain all necessary permits before commencing any electrical work. In conclusion, safety is paramount when working with electricity. Always consult with qualified professionals and adhere to all applicable codes and regulations to ensure safe and compliant electrical installation.